Okay, let's look at some more trig derivatives. So for number 1, we want to find the slope of the graph of t of x, which is equal to 2 sine of x plus 3 cosine of x at x equals 0. Okay, so remember, slope uses the derivative. So we need to be looking at the derivative equation. So I'll do t prime of x equals the derivative of sine is cosine, and then the coefficient will just stay. So this isn't a product rule. This is just a regular derivative. For it to be product rule, it would have to be a 2x times sine of x. So here's the derivative of the first term. The derivative of cosine is sine, or is negative sine. So that's going to become negative 3 sine of x. Okay. So there's my derivative. Then I can just plug in 0. So that'll give me 2 cosine of 0 minus 3 sine of 0. Okay, remember that 0 is an angle measure. So we're over here on the right. Cosine is our x value, sine is our y value. So that's going to be 2 times 1 minus 3 times 0, just giving me a slope of 2. Now for the next one, this time they want the equation of the tangent line of f of x equals 2 cosine of x plus x at pi over 2. So for the equation of the tangent line, I need y minus y1 equals m times x minus x1. Okay, well I already know my x1. I'm going to go ahead and set up what I know. Okay, so I have y minus, I don't know that part yet. I don't know the slope, but I know it's x minus pi over 2. Okay, so remember, to get the y value, that comes from the regular equation. So I'm going to take x, plug in pi over 2. So that'll give me 2 cosine of pi over 2 plus pi over 2. Okay, so cosine of pi over 2 is up here. Cosine is our x value. Okay, so pi over 2, the x value would be 0. So this is just going to be 2 times 0. Then that pi over 2 just stays. So 0 plus pi over 2, that's just pi over 2. So that'll be my y1 value. Now I need to find my slope. So the slope, that's from the derivative. So I'm going to go back to f of x, and I'm going to take the derivative. So I'll have f prime of x. Okay, the derivative of cosine is negative sine, so that'll be negative 2 sine of x. The derivative of x is 1. Okay. And now I want the slope when x is pi over 2, so I'm just going to plug in a pi over 2. So that'll be negative 2 times sine of pi over 2 plus 1. Okay, so I can go back here. Pi over 2 is up at the top. The y value here is 1. Sine always goes with the y value. So that'll be negative 2 times 1 plus 1, which is going to give me a slope of negative 2. So then I can just go back to this equation here. Sorry, my slope is not going to be negative 2. My slope is going to be negative 2 plus 1, negative 1. So then I can just fill in my slope of negative 1. So on this next one, determine where the graph of g of x has a horizontal tangent line. Okay, so now they're telling us, they're not saying find the equation of the tangent line or find the slope. They're asking us, where do we have a horizontal tangent line? Well, I know when something is horizontal that the slope is 0. Okay, and we know the slope, I guess this would be a g of x. The slope is the derivative, so we're looking for where the derivative is equal to 0. So step 1 is I'm going to go to my function, take the derivative of sine is cosine, the derivative of x is just 1. Okay. Now I can take that derivative equation. I'm looking for the x value where the slope, so where the derivative is equal to 0. And now I would just solve this trig equation. So I'm going to subtract 1. You need to get the trig function by itself. Okay. Cosine goes with x. Okay, so I'm looking for where the x value is -1. Well, that would be over here on the left. So that means at x equals pi, okay, and at every angle coterminal with this one, y'all can just put the first x value in that first rotation. So at x equals pi, we're going to have a horizontal tangent line. Now let's take a few more derivatives with trig functions. So this one, I have a 4x squared times the cotangent of x. So I'm multiplying two functions that both have x's. So we're going to have to do the product rule. Okay, so 4x squared is going to act like f. Cotangent is going to act like g. Okay, there's no way to multiply these together and combine them. So my setup for the product rule, I'm going to leave 4x squared the same. Then I'm going to multiply it by the derivative of cotangent, which is negative cosecant squared. Then I'm going to take the derivative of 4x squared, which is 8x, and then I'm going to leave cotangent the same. Okay. So I can multiply these coefficients, the 4 and the -1. And that'll be our derivative. Okay. You can, if you want to, GCF out a -4x. A lot of times if there's an x I can GCF out, or a common factor that has an x, I'll take out that GCF. So that would leave me with a positive x cosecant squared. Then it would leave me with a -2 and then a cotangent. So either or is fine on this one. Then if we look at our next one, okay, so I have secant times cosecant. Okay, so since you have an x times another x, we're going to do, again, the product rule. There's no way to combine these. Even if we used our reciprocal functions, you would still have a trig function times a trig function in the denominator. So for my derivative, I'm going to have cosecant of x, and then the derivative of secant is secant times tangent, so those are all just multiplied together. Then plus the derivative of cosecant, that is negative cosecant cotangent, then leave secant the same. And again, they're all just multiplied together. I didn't put any parentheses there. Okay. And then I'm just going to, instead of writing plus and negative, I'm just going to rewrite this as minus. Okay, so you can leave your answer like that, or you can take out the GCF, which both of these have a cosecant of x and a secant of x. So I'm going to take a cosecant, secant of x out for both terms. I'm left with a tangent and a cotangent. So I'm going to leave my answer like this. It just looks to me a little bit neater than the original. Okay, so here let's just look at some of these and talk about how you would take the derivative. So these first three, you've got a 3x times a tangent. You've got an x cubed times a cosine, a tangent of x times a sine of x. So both parts have an x, and there's no way to like multiply those out. So for these first three, you're going to have to use your product rule. Okay. Now if I look here, this is just a regular derivative 11. I can just go term by term. Okay. This 1 over x, I'd have to move it up first, and then I can just do my secant derivative, my sine derivative, and just do the regular one. If I look at number 10 though, okay, this is one where I could do the quotient rule, but if there's a way to not do the quotient rule, that derivative is usually easier. So on this one, I would split it up first. I would do sine over cosine. So sine over cosine, that's tangent. Then I would do 1 over cosine, which is secant. Okay, so remember, if you just have one term on the bottom, you can always split it up. Take everything on top, divide it by what's on bottom. And then that is just a very easy trig derivative. Do the derivative of tangent minus the derivative of secant. Okay. So if I look at one like number 12, since there's 2 terms on the bottom, this is where you have to do the quotient rule. So this is the time you don't have any other option. Okay, but again, one like 13, since there's 1 term on the bottom, I would take everything on top, divide it by x cubed, and just do my regular power rule derivative. And then if you look at ones like 16 and 18, okay, 18, you're going to need to rewrite this as 3x minus 1 times 3x minus 1. And then from here, you could either do the product rule, or then you could FOIL it out, and once you FOILed it out, you could then just do your power rule. On 16, I would go ahead and distribute in that cosine, and then you would have cosine over sine, which is cotangent, plus 2 cosine, and then you could just do your easy trig derivatives.